This is a profile from Transformer Technology. I'm Alan Ross. I'm the editor-in-chief of the magazine Transformer Technology and the curator of the digital community that we've got in Transformer Technology. My guest today is friend Dennis Reid, the founder and CEO of H2scan. Welcome, Dennis, and thank you for joining us.
And you too, Alan. Thank you very much for having me.
Okay, so Dennis, you and I met through some industrial espionage because I wanted to find out who was the manufacturer of this wonderful hydrogen monitoring system that seemed to be taking the market by storm, and a supplier of ours who was using your technology was not would not come forth because they knew what I would do, which is go directly to you and say, "Hey, Dennis, we've got a thing. Why are we buying through a third party?" And I met you. We've had kind of a nice. I think I could be your best salesman, right? And I could actually tell me a little bit about how you started with a company called H2scan as the founder and CEO.
Well, I originally was an investor in the predecessor company, a company called DCH Technologies, and they had licensed the technology on a non-exclusive basis from Sandia National Labs. And so I started looking into the markets that for their hydrogen sensors. They were mostly into, at that time, spending most of their money on fuel cells rather than sensors. But my heart was in sensors. And so I started looking into the need and where the gaps were in the technology that was available in the marketplace. Really got me intrigued by the technology that DCH could develop. And I felt like that was something that I could build a company around. I ended up putting together a venture capital fund or using venture capital money and started H2scan, and here we are.
Here we are. We're going to talk a lot about it. I want to talk about now that you've gotten into it. It's kind of like the minute I got involved with transformers, I started having transformer liquid flowing through my veins. You get to the point that you fall in love with the beast. I know you're that way with hydrogen monitoring. But one of the things that the industry, it's not like there haven't been hydrogen monitors. Kelman was out there doing it a long time ago. And I think I've told you this before. I've probably seen more transformers with Kelman monitors that weren't working, and you wonder why people had them on there anymore. And if they thought they were working, they weren't. There's unique technology. You've done some things differently. And one of the things I admire the most about H2scan is the quality. And I think there's three things: the quality, because I know that was the thing that initially caught my attention, the accuracy, the cost effectiveness of it. And I think if you look at those things, they're all in there. Now, those are the solutions that you bought. But what I want to ask you up front is, I believe everything simply boils down to this. Number one, what's the problem you're trying to solve? Number two, what's your solution? And number three, how do you implement that solution? So with that said, you moved into the monitoring area, you looked at hydrogen, you must have looked at the marketplace, but what was the problem that you think is out there that you want to solve?
With every technology that was available when I started H2scan, there was a gap in what the market really needed versus what the analyzers actually did. And so if you start out by the gas chromatograph, with that time was a sample, you could do about 8 samples a day. So the market really was asking for real time. So then what was available was the thermal conductivity sensor, and that had a lot of issues when it came in contact with H2S and CO. And so I felt like that the technology that Sandia had started could be developed into be an all-in-one sensor, so that sensor could be used in virtually any application, from petrochemical monitoring in a refinery to safety, all the way to being able to monitor the oil inside a transformer. And so that's what really motivated me the most about the technology, because I really felt deep inside that given the right money, and time, we could develop a sensor that basically met all the needs of the marketplace and filled these gaps.
I think it's interesting because you gave a little bit of a hint into the future of H2scan. You're exactly right. In this case, we're going to be talking about transformers and hydrogen monitoring and transformers and why hydrogen and all of those things. But the future's so bright, you got to wear shades. If I had sunglasses on, I'd put it on, because the technology that you've proven in this industry applies to so many more industries. And you mentioned safety. You know, hydrogen sulfide is a really bad gas inside of a refinery, right? I mean, pretty much immediately fatal. And so there've been a lot of ways to do it. So I really think H2scan and the, I guess, your pedigree and everything of how you've done it does have applications. So now let's get back to what I love, transformers and what it means for transformers. There's two things where there is a paradigm, and we got to make the paradigm shift. One of them is continuous monitoring versus, hey, every quarter I do a DGA, once a year I do a DGA. So it's the idea that you do a time phase monitoring versus continuous. That one I want you to address. The other one is, well, why hydrogen? Why not spend $1,000 and do all 9 gases? Why hydrogen and spend a lot less money? And so there are people that don't really sell just the hydrogen. They don't really work in that market. They're trying to, we've got people at that we love and respect and have articles written about that are talking about a more advanced monitoring, and we'll get into that. But talk to me a little bit about the defense of hydrogen as a signature gas with a fault in a transformer.
Yeah, what we've seen, especially now with this pandemic, is I think even moved it forward even faster. But we're seeing that the utilities, okay, there's enough failures at the utility that taking a sample once a year, twice a year, that's a big gap between those two times. And so to have a real-time monitor that's on there that can give you an early warning device, similar to going in and taking a blood test. You might not have cancer, but you take the blood test often enough and you're going to be able to pretty much, and many times, okay, discover that you've got a problem coming in the future, right? And so that's what we set out to do. One of the biggest issues in the industry at that time, you ask about solving problems, was that the current analyzers that were on the market, many of them failed, okay, at startup. They popped the membrane under pressure, and it caused the analyzer to be useless. And so we wanted to create a sensor that you could put directly in the oil, not in the headspace. And we wanted something that would be at a very low ppm and go to a much higher temperature than what was on the market. And so that's the product that we developed, and thank goodness we were successful. And now we've attracted the attention of the largest companies in the world, or pretty much using H2scan as the gold standard, okay, for monitoring hydrogen in a transformer.
Now, we both have agreed, Dennis, that we're not going to name any of those biggest companies in the world, but I can attest to the fact that it's the biggest transformer manufacturers and biggest transformer monitoring people in the world. So kudos, and it is working there. So why hydrogen? I mean, I want to go back into a perimeter. We assume that everybody here knows that hydrogen is a marker in any sort of a failure. You're going to get all kinds of gases, methane, ethane, acetylene, and in combination, that means something, right? So we do know there's IEEE just came out with their new DGA gas guide, and it's got hydrogen is in all of them, and everybody says, oh yeah, hydrogen is going to be all of them. Now, it may be a leading indicator gas or a lagging indicator gas, but if you were looking at the cost benefit ratio, why is it that you can make a case that hydrogen will protect you to be able to not determine the fault? Maybe the other gases can help you actually know what it is. Hydrogen is the gas that tells you got to go in, pull the sample, because every monitoring company I know says, if you get an alarm and alert, what do? You pull a sample. And then that sample is something from a DGA that you look at. But talk to me about why you are so passionate about hydrogen as that leading gas.
I think it's for me, it's the utilities were already using labs, okay, as being the gold standard for determining every single gas in the transformer and what that meant, okay, in relation to potential fault in the future. And so that they are the ones, utilities set up, okay, the perfect storm for using a hydrogen only analyzer, because if there's something going on in the transformer, it's going to create additional hydrogen. Okay, in some cases it won't create additional CO, it wouldn't create additional moisture, it wouldn't create a lot of things, but it will create okay, additional hydrogen. And if you've got a hydrogen monitor that can measure down in the very low ppm, and you can see those rate of changes, okay, that are happening, then something's going on. And so, and that is the reason I think that many utilities now are going to a single gas monitor, and some of them are including moisture and temperature. But the one gas that they want to monitor to make sure that they always know that there's something going on in that transformer is they measure hydrogen. And I think that's where we have come in, and that's why we're, as successful as we are today.
You're the zigzagger. You're moving the other way. You're saying, how do I bring a more cost-effective, that's the word, I'm not going to say cheaper, but a less expensive, more cost-effective product to market? And I think that's your Gen 4, or you tell me about it, because I think that's a brilliant way to go to market, to give people an opportunity to put more of them out there cost effectively. Talk to me about kind of where you are in that marketplace.
Yeah, thank you. Well, we've had several iterations and throughout the years, but the largest seller that we had up until we developed this new product was what we call Gen 3.5, and that was sold mostly as a subassembly. Even SD Myers, okay, was buying the subassembly, and then we've helped use those subassemblies to create so many products in the industry, all the way from single gas monitors all the way up into the 10 gas monitors that some of the largest companies in the world offer. And so we wanted to have a product. We went out and we did surveys with several utilities to find out, okay, exactly what sort of a product that they would need to monitor their lower cost assets, because at that time, the utilities just were not monitoring any distribution transformers, because they couldn't put a $10,000 monitor on a $5,000 transformer. And so we set out to use the vast experience that we had in the hydrogen sensor to create a product, okay, that could be put on a $1,000 transformer, $5,000 transformer. And so we created what's called the Gen 5. That Gen 5, as all of our products have, it has a auto calibration feature where you put it in the transformer and put it on the transformer, and you leave it, and it's plug and play for 10 years. Okay, and so no maintenance required. It does auto calibration on the spot, no gases, no nothing. And with that, then we wanted to have something that we could basically, sell for, somewhere between $1,000 and $3,000 with volume. And so that allows, okay, and it has the same specification as the same sensor that they're putting into a $3 million transformer. So we took our base technology and created a product, okay, that was basically able to be put on a very low cost asset. And it's made a huge impact in the marketplace. And we now have increased our OEM supply agreement customers, okay, about 3 times what we had prior to the existing models.
I love that. I think that is a game changer in the industry. But the idea that we could get more of them out there, as a reliability person, because that's really what my background is. I am the head of the Electric Power Reliability Alliance. Notice how I slipped that in there as the president and founder of that organization. It's primarily for industrial and commercial, but what you've just given that marketplace is something they couldn't afford, because $10,000 is too much to them. Forget a 90,000, 70,000. You've given them something that I can now go to that market and say, continuous monitoring. You can do that to your transformers, because they have all these distribution and secondary feeds that they've got to keep running. That, if a transformer goes out, there's $1 million of product a day that doesn't go out. So our passion at EPRA is to bring electric power reliability. And one of the things in reliability is online monitoring. The next thing, and the last thing I want to talk to you about, we will have another discussion. We're going to do more of these. But Dennis, the next thing is how people are using data. Is it like
it takes a reading every second, Alan? And
okay.
Currently today we offer hydrogen only in the Gen 5. The Gen 5 was created with a built-in ASIC, so we were able to reduce the electronics down by about 85% of what the normal system would cost. So it's an all-in system, okay, that has built-in power supply. It goes from 25 ppm all the way to 5,000, goes from -40 to 105 degrees C. So the basics for the specification we had down. And
Right.
so we built that Gen 5 to accommodate multiple sensors. And so where we're going and where I think it fits H2scan and the IIoT of things that is making waves in the industry now, we do plan on using the Gen 5 as a platform, same head, benign to the end user, but we have the ability to put two ASICs in that same head, and it's built that way. And then we put two of our customized patented flex circuits where we can mount multiple sensors. So not only will we offer hydrogen, but we will also offer moisture, and we'll offer temperature and pressure. Now we'll have four sensors that are basically the backbone of every system that has all of those sensors in there, but they're paying a very large amount of money, okay, for adding all those sensors. We can do it on a semiconductor basis, so it costs us literally pennies on the dollar versus what somebody else is buying it for. And so we'll be able to offer a multi-sensor configuration for the distribution transformers and still be in a price range where they can afford it to put on their lower cost assets. And to me, that is going to be one of the biggest game changers that has ever happened, because we're gonna drive that price down by literally thousands upon thousands of dollars versus what it is today. And we'll allow I want to get to $1,000. And the reason I do, because I want a utility to put an H2scan sensor on every single transformer that they make. And one manufacturer alone makes almost 200,000 a year. So
Right.
that alone, okay, equates to a lot of volume.
And I will tell you that if you were to ask me, and this is as a transformer expert, if I could do one thing, I would do hydrogen. If I could do two things, I would do hydrogen and temp. People
Yep.
argue and say, no, the next thing ought to be moisture, but you get my point. Whether
Yep.
it's temp or moisture, it really, if you can do those three, boy, you're really ahead of the game. But when you add pressure, so you add temp, pressure, that's brilliant. I mean, if you do that, we're going to come back and we're going to talk about this and saying to the marketplace, you heard it here first.
Yeah.
Dennis, this has been wonderful. I love your passion for this. I love the fact you got into it. And at Transformer Technology, EPRA, we really support and back what you're doing. This has been a profile from Transformer Technology in the community. It's also an interview that you will see in an article in the magazine coming up. Our guest has been Dennis Reid. He is the founder and CEO of H2scan. Watch them. Watch what they do, and it's fun, because what you're doing, Dennis, is going to change the reliability capability of the utility world, of the industrial world, and of the commercial world by measures beyond where we are today. So thanks for that.
Thank you, Alan.